Let's use a graph of a function to answer questions. Our graph today has the classic W shape. That means it is going to be a function of degree 4. Let's focus in on the zeros of the graph. Those are the places where the graph interacts with the x-axis and places where y is 0. So these are called zeros or roots of this graph. We have roots at -5, 1, and +5. So let's just list that. List our roots and also list our factors. So the first root or 0 again is -5. X equals -5. So its corresponding factor will be x plus 5. The next root or 0 is +1. X equals +1. Its factor will be x minus 1. The final 0 or root is +5. X equals 5 with the factor of x minus 5. So we have to recall what we know about multiplicity. The 0 in the middle is different from the other two in that the graph comes up, approaches the 0, touches it, and turns around. It bounces off of that 0. It does not go through that 0. So I know that this multiplicity is even, and the other zeros have odd multiplicities. Odd, even, and odd multiplicity. So when I look at the factors, I know this is a degree 4 because of the shape of the graph. And so if this is going to be even, then the power on that factor is 2, and the power on the other two factors are 1, for a total of 4, degree 4. 2 plus 1 is 3, plus 1 more is 4. So I have a look of the what my factors look like. I have an idea of what my factors look like. I need one more point, and I'm going to focus in on this point here. It is the y-intercept. The other three were x-intercepts. It's where the graph intersected or connected with the x-axis. This point is important also. That would be the ordered pair 0, -1/2. Okay, so I am going to label that 0, -1/2 for this intercept. 0, -1/2. And so now I am going to answer some questions before we get to the final question. Part A, list all roots with even multiplicity. If more than one such root exists, use a comma-separated list to enter the roots. So we only have the one even root in the middle, and that is at x equal 1. So x equal 1. If it didn't interact with the x-axis at all, we would have to check no roots have even multiplicity. Part B, list all roots with odd multiplicity. Well, we had two of those, the +5 and the -5. So in this case, x equals -5, +5. Okay? And then, finally, well, not finally, but part C, determine the y-intercept. Report the solution in x, y format, in ordered pair format. And we did estimate the y-intercept here at 0, comma, negative 1/2. 0, comma, negative 1/2. Now, finally, determine the factored form of the polynomial f. Well, having those factors is really going to help us with that. So let's work on that. The equation y equals, we're going to put a, and we're going to list our factors. We have x plus 5, that was raised to the first power. We have the quantity x minus 1, that had an even multiplicity, so it's raised to the second power. And we have a factor of x minus 5, raised to the first power. Now, we need to be able to use our y-intercept to help us find a. So we need to plug in our point. We're going to use this point to help us solve for a. Because in this point, we know that x is going to be 0. And we know what our y value is. We'll substitute y for negative 1/2. That will allow us to find a, because we only have 3 variables. We have y, we have a, and we have all of the x's. Everywhere we see an x, we're going to substitute it with 0. So let's do that. 0 in for x, negative 1/2 in for y, and a is still unknown. So we're going to rewrite everything else. Everything else remains the same. A, open parentheses, 0 plus 5, times the quantity, open parentheses, 0 minus 1, squared, open parentheses, 0 minus 5. And we clean this up a bit. I'm going to go ahead and rewrite negative 1/2 as negative 0.5. Just going to change it to its decimal form. A remains the same. 0 plus 5 is 5. 0 minus 1 is negative 1, all squared. 0 minus 5 is negative 5. We need to square this negative 1. Negative 1 times negative 1 is positive 1. We need to multiply these numbers together. Negative 5 times 1 times positive 5. That's going to give us a negative 25 times a. Now, we need to isolate a. To get a alone, we need to get rid of multiplied by negative 25. I want to clean the decimals out of this equation first. And to do that, I am going to move this decimal once to the right. There's an understood decimal here that I'm going to move once to the right as well. What I do to one side, I have to do to the other. So really, I've multiplied both sides by 10, and that's valid, and that helps me get rid of decimals out of my problem. So this is how this looks. Negative 5 equals negative 250a. So I move the decimal, I insert another 0 here, so I get 250. Now I'm ready to get rid of negative 250. Divide both sides by negative 250. And simplify. Negative divided by a negative is a positive. That's gone. 250 goes into both of these numbers once each. 5 goes into both of these numbers. Again, negative divided by a negative is a positive. 5 goes into 5 once. 5 goes into 250 50 times. So I'm left with the fraction 1 over 50 equals A. So I know what A is now, and I go back and insert it into this top row, and I can write my f of x. So f of x equals, substitute my A value, 1 over 50, and record all of my factors. X plus 5 times the quantity x minus 1, quantity squared, times x minus 5. So there we have it. If you're working with the handout, there was a typo. There was degree 3. This was not a function of degree 3. It is a degree 4 because of the W shape. Thank you for visiting Math Made Simple with Professor Vernette.